All right, this is our first lecture on section 5.3, function notation. Our objectives are to describe function notation and learn how to read it and how to use it, to evaluate and to describe a linear model, and then finding the inputs and outputs of a model, and including in that how to use the function notation to do it. So first of all, let's describe what function notation is. It's a way of describing the dependent variable as a function of the independent, and it's written using both variables for the dependent and independent values. And on the outside is the letter that represents the values of the dependent, and then within parentheses we have values that represent the independent. So what we normally see as our general function notation is an f with the x in parentheses. This is read f with x or f of x more typically, and the dependent value f of x is our y value. It's really important that you realize that when I write f of x, I'm actually saying that's y. And so here are some pointers on how we can read these things. So when I say f of 3 equals 5, that's the same thing as writing the ordered pair 3, 5. That means x is equal to 3 and y is equal to 5. And then finding f of 3 is like saying let x equal 3 and then evaluate an expression, and what that expression's value is equal to is the function's value. So let's try that with a couple of examples here, 9 and 10. So in example number 9, we have a function, f of x is equal to 2x plus 5. And we want to find f of 2. So in order to find f of 2, what this is saying is let x equal 2 and find out the value of this expression 2x plus 5. So this says 2 times what x equals, which is 2, plus 5. And so that says 2 times 2, which is 4, plus 5. And 4 plus 5 is equal to 9. So f of 2 is equal to 9. And another way of writing that, remember, would be to say that our x is equal to 2 and our y is equal to 9, or as writing the ordered pair. Now the next one, it says let's find the y value when x is equal to negative 1/2. So this says 2 times the x value, negative 1/2, plus 5. So 2 times negative 1/2, negative times a positive is a negative, 2 times its reciprocal is 1, so that says negative 1, plus 5, and so that gives us 4. So this says f of negative 1/2 is equal to 4. And remember, that is like saying that x is equal to negative 1/2 and y is equal to 4. So I'll write that over here, although that's not what I'm going to box. So x is equal to negative 1/2 and y is equal to 4. And there we go. All right, now we're going to do our next example, example number 10, and we're going to do this for h of 1/2. You might want to pause here and do h of 1/2 on your own. Okay, now we have 1 over whatever g is, and g is 1/2. Now you'll notice that our variables changed. It's not f of x, it's h of g. That's perfectly acceptable. Now students get a little confused by this one sometimes, but remember, this says 1 divided by 1/2. And once you put it in those terms, you can certainly do this problem. This says 1 times reciprocal of 1/2, which is 2. So this says 1 times 2, which is equal to 2. So h of 1/2 is equal to 2. And that means, again, x is equal to 1/2, y is equal to 2. Now h of 0 is kind of special because you know what happens when we divide by 0? That's undefined. And that leads us to an important point, that the functions do have domains, and domains mean what numbers will make this function work, won't allow them to be undefined. So this note down here is really super important because that leads to the fact that functions have domains, and the domains mean that we can't have an undefined value come out. So our next example is going to show us functions